Okay, welcome back. Now we're talking about this idea of this equivalent class. Well, for example, 5 has 5 different equivalent sets. Okay, and so a great thing about this equivalent set is we could use them interchangingly, which means let's say if we encounter some big number, let's assume let's say we have the number 250. Well, you could basically replace 250 with this very small number we have here as of 5. So this is the beauty of this equivalent set, and the idea of even learning this modular arithmetic and all this equivalent set is to be able to perform mathematical computations a lot faster. So for that, let's actually look at another example. Let's look at the equivalent set for 7. Okay, for 7 we'll have a total of 7 of them. So let me just use only the positive numbers. Let's start with the 0. Okay, to 7, 14, 21. Let's get 1, 8, 15, 22, and then it just goes on and on. Okay, so 2, 9, 16, 23, and so on. We have, let's say 3, so 0 is done, 1 is done, 2, 3, 7 is done, 3, 10, 17, oh god, 24, 4, 11, 18, and so on. So got 1, 2, 3, 4, 5. Well, a couple of more to go. 5, 12, 19. Got this 6, 14, 20, and so on. Okay, so this is my equivalent set of 7. Here we have 1, 2, 3, 4, 5, 6, total of 7 of them, and we should be getting everything from 0 to 7. So we have 0, got 1, 2, 3, 4, 5, 6, and then the 7 right here. Okay, now I would love to use this equivalent set to do a computation. Okay, and the computation I have is this number 3 to the power of 8. Okay, so this equals to 6561, and I would love to basically decode it in the mode of 7. Okay, and well, the idea of it is we have this number. Let's assume this number as a 6561, and if you remember, we got familiar with this technique, drawing things with this r mod m. So let's break it down in this form. Well, if you try to break it down, it's going to be extremely hard. So 6561 is here. Okay, we don't know what the r is. What we know is we got the mode of 7, and we can basically try the trial and error and then reach there, right? So to reach here, well, first of all, let's try to multiply it by some number. It turns out the number is 9 with 7. Okay, we multiply it by 7 plus 2 will give us this exact number, which means the remainder here is 2. So now to get this remainder, we'll have to go through a lot of mathematical computations, and this, well, it's great, but it's not fast enough. Okay, so we'll have to use the power of this equivalent class and come out with something a lot better. And I use this 3 to the power 8 for a reason. See, we can use the power rule, okay, the things we studied in our high school days, and compute the remainder a lot faster. Okay, so 3 to the power 8 is equivalent to, well, 3 to the power 4 times 3 to the power 4. We could basically add the power, right? And 3 to the power 4, well, what are they? 3 to the power 4, 3 times 3, 9, 3, 27 times 3 is 81. So I've got this 81 in here, 81 times 81. And since it's mode 7, we could basically use mode 7 in here. So 7 times 10 is 70, times 11 is 77. I've got the remainder of how much? 4. So eventually it just breaks down to 4. Now it's going to be a lot easier to do the things, right? So 4 times 4 is 16. Now instead of this bigger number 6561, I can just replace it with 16. So this is the power of the modular arithmetic. So I can now use 16, okay, for this mode of 7. So 7 times 2 is 14, remainder is 2. So I can now easily get the remainder. And I forgot to mention something here. So this 81, I basically divided it by 7. I got the remainder here as 4. But it turns out this 81, okay, is part of this equivalent set. And it turns out this 81 falls within this specific. So if you just go here as far as possible, you will reach 81 in there, which means you basically can replace this 81 with a very small number of 4. And to get that, we could directly get it by basically dividing it by 7 and putting in the remainder. So this is one of the beauty of using this modular arithmetic. And believe it or not, these competitions are performed in computers every single time we're making some request on the internet. So it basically uses the same idea. Well, the only thing is, instead of having 3 to the power 8, it could have 9 to the power, I don't know, 100, something like that. So it's going to be astronomically huge computations. I mean, not this one, but I don't know, 9 to the power 10 something. So it's going to be astronomically huge computations computers perform every single time we're making the request. And for that, well, even computers have to use the techniques just like the one here in order to perform those operations, because, well, I mean, it's computer, but the thing is the numbers are really huge as well.